Good afternoon, good morning, and good evening. It's Joe Drumgoole here from MongoDB. I'm Director of Developer Advocacy at MongoDB in EMEA. You're joining Part 5 of the Back to Basics series for MongoDB. Congratulations if you've made it this far and if you've been at all the other recordings. Only one more to go, and we'll have to see if we can dig up something as an award for people who turned up for every one of them. Before we get started, I just want to draw attention to one thing. MongoDB Europe, our first ever European-wide event, will be happening on the 15th of November in Old Billingsgate, London, which is an absolutely fantastic venue right on the waterfront of the Thames River. We're finishing super early bird discounts on Friday. But if you register today, you'll get 20% off that super early bird price. And if you register with code JD20, that'll entitle you to 20% off. The super early bird discount ends at the end of this Friday, and then it'll go up to early bird. So it'll be another 10 or 20 euros on the price. So there's a big opportunity to register now. And of course, if you register in groups of 3 or more, you get another discount. So you're going to get your super early bird discount, you're going to get a 20% discount for JD20, and you may get another discount if you register 3 people. So it's a huge chance to get a great deal on what's going to be one of the most amazing MongoDB events. We've got a lot of great speakers lined up. It's going to be a fantastic day. There's going to be ice cream and sweets and technical talks. We're going to get lots of the executives over from the US. I really think you'll have a great time. With that, let's get started. This is Back to Basics Webinar 5, Introduction to the Aggregation Framework. Probably one of the least understood and least well-known capabilities that anybody who's using MongoDB should understand and have a grasp of. Just to give you a quick recap of where we came from, Webinar 1 was about an introduction to NoSQL. We talked about the different types of NoSQL databases, and we explained that MongoDB is a document database, as in JSON documents, not documents that you find on your laptop or in your Office suite. In Webinar 2, we showed you how to build a basic application and showed you the basic operations for CRUD changes to the database, how to add indexes, and how to use an explain plan to find out whether your queries were performant or not. Webinar 3 gave you more insight into schema design. We talked about dynamic schema and how you could design a schema that was based around a document schema rather than the traditional relational database schema. And in that situation, often what you find yourself doing is embedding more content in a single document than you would have normally scattered across a range of tables. And we went through the various approaches where it makes more or less sense to add a document or to keep a document in a separate collection or a separate table. Then last week we talked about the 2 new kinds of indexes that you may not have come across before in a standard relational. Geospatial indexes that allow you to search using the location of an object and its proximity to other objects in the database. So effectively by saying queries that say, I'm here, what's around me within 50, 100, 200 meters, a mile. And we talked about full text indexes, which are essentially indexes that allow you to search inside a record inside a document. So imagine you have a document that contains a free text field that might be the comment in a blog. Text indexes allow you to look inside that field and index each word. And full text indexes are a very important asset and aspect of searching inside a broad-scale database. So, the aggregation framework. The aggregation framework is essentially an analytics engine for MongoDB. And what do we mean by analytics? Well, think of the 2 types of databases that we're most commonly using. They're either online transaction processing or online analytical processing. And these databases do 2 different kinds of things. So online transaction processing is typically airline booking, ATM transactions, booking a taxi with Halo or Uber or whatever your favorite taxi app is. They have a couple of characteristics. One, they need real-time responses. I need to know within a matter of seconds to minutes what the outcome is of my booking, the outcome is of my cash withdrawal, the outcome is of whether I'm going to get a taxi or not. So they're real-time. They must respond in often sub-second time frames. And if they don't, well, people stop using them. So it's all about getting that fast request in, getting a fast response back, and updating some record in the background that basically gives us an audit trail of what was done, what money was withdrawn, what tickets were booked, what taxi was allocated to us. Online analytical processing is effectively using that historical data, the audit that was collected, to do more detailed analysis. So you might ask an online analytical processing system, which tickets make us the most money in an airline? What days are the most successful days for booking? What is the best time to discount a ticket? When is the best time to sell full price tickets? Or when is the best time to refill our ATMs? When is the cash demand greatest? When our ATMs need to have a very low cash amount in it, because obviously there's a risk with an ATM carrying a lot of cash for a long time without it being withdrawn. And how many cabs do we need to service the West End of London or Lower Manhattan or Southern Bangalore? If we don't have that data of usage and if we can't analyze it, we can't answer these questions. And what does it look like? Well, OLTP is essentially characterized by large numbers of requests and responses, reads and writes, that update very small fragments of information, often even a single row in the database. So what you're really looking for is a database that can respond very fast to row-level updates, row-level writes, and row-level reads. On the other hand, online analytical processing is much more about asking the database about a query that may return a very large subset of the data, maybe even half the data or a quarter of the data, because what we're doing is we're saying, give me information about all the flight tickets I booked in the last year, or give me information about all of the taxi cab journeys that our service provided in the last 6 months. And so those analytics typically look at a very large slice of the data, and they're often read-only. We don't actually need to do the analysis we're doing. Missing the last even couple of days of data isn't a big deal for us. This is why online analytical processing systems are often loaded by ETL processes that essentially shove data into the system, and it's typically eventually consistent. It's out of date with what's happening in the current online transaction processing system. But there'll be dragons here, and by dragons I mean Hadoop dragons. Because OLAP queries are often table scans, the output of the queries is often stored for future analysis and comparison. Many customers look at Spark and Hadoop for OLAP, but beware. The complexity of deploying Spark and Hadoop solutions can be astronomically high, not to mention the cost. And it's focused on algorithmic analysis of your data. It's not just queries, it's essentially running a program that's distributed over your data. So in order to make Spark and Hadoop work, you need some significant knowledge of parallel algorithms and parallel processing. Without that knowledge, you're going to find it very challenging to run Hadoop and Spark queries on your data set, regardless of where it's stored. And both Spark and Hadoop are able to work with flat files or their own storage system, or indeed MongoDB. MongoDB has a connector for both Spark and Hadoop that's dedicated and optimized for those environments. But for a lot of the queries that we want to do in MongoDB, the aggregation framework is a kinder, gentler tool. It's easier to use. It models and depends on what you've already learned about the database from the query language and from the structure of the documents. And often it may do what you want in less time with less anguish. So we would always recommend starting with the aggregation framework, and as the complexity and the challenge of what you're asking the database grows, then you can grow up into using the Hadoop connector, or indeed the new Spark connector that we announced at MongoDB World a week or so ago, which will give you the ability to do those algorithmic analyses of the data. And ultimately what we're doing with this kind of query is we're making new data from old. We're taking the data, shaping it and transforming it, or computing new values from the old values. And that's the essence of what the aggregation framework gives you, is this ability to take a subset of data, reshape it, transform it, and produce a new set of data. And the aggregation framework can be thought of as just a processing pipeline. Think of the Unix pipes of old, right? The output of one stage is passed to the input of the next stage, and each stage performs one specific job. You can repeat the stages, although there are some limitations which I'll go into as to which stages can appear at the start and the end. And the input is typically a single collection. We do have a join operator which can take data from more than one collection, but by and large it expects one collection coming in and one collection going out. And there are a range of pipeline operators. Now, the pipeline operation subset is large, and I wouldn't want to go through it in one presentation, nor would I want to overwhelm you with the amount of capabilities it has. But I'm going to go through some of the key things that every pipeline needs to know about. So the key operators that you'll definitely see a lot of, regardless of what you do with your pipeline, is match. Match is effectively using the find query language that we talked about in the earlier webinars to select a set of documents. So I might say, as the start of a pipeline, I want to see all documents after a particular date, or I want to see all documents with a particular field value above this value, or all documents with a field value equal to this value. Then we have project. Projection is about reshaping documents. It allows you to rename fields. It allows you to select the fields that you want to appear in the next stage. It allows you to do computations within a document. So you could take two fields and add them together, or you could take the substring of one field and make it become a new field, or you can rename a field name. Once we've done the projection, then we often want to group the documents. This is the group by capability that we've talked about or that you can see in relational databases. So a grouping is effectively saying, for some set of documents with an identifier, with a shared set of attributes, let's take that shared set of attributes and compress it down into a single value. So you might say, for all makes of car called Audi, I want to find out what the total average mileage is. And a group by essentially takes in that value and compresses it down by doing an accumulation on a set of values. I'm going to show you an example of this. It's probably hard to visualize without seeing a real-world example. But essentially it allows you to compress the document. You can do it actually is the core of the aggregation framework. It allows you to do a summation on a set of values and produce a smaller set of values as an output. Then we have $out. $out always has to appear at the end of the collection. $out essentially creates a new collection from the output of a pipeline. And it's very useful when we've essentially reached the point at which we want to create a new subset of data from the original input data. And $out is just a pointer to a new collection that's generated. Then we have $sort, which will essentially run a sort function on the documents if we wanted to get them grouped by the largest value to the smallest value. Then we have limit and skip. Limit is used, and it's very useful at the start of a pipeline. It effectively controls the number of documents you're going to let through to the next stage. So if you've got a large collection and you're testing a pipeline operation, we would typically limit the number of documents we were pushing in. The collection I'm going to show you in a few minutes has over 34 million documents. You don't want to run each test by having it parse 34 million documents. Skip does the same thing. It will skip over documents if you wanted to reach into the middle of a collection. Then lookup does join. It will take two collections and join together. It's a left-outer join if you remember your relational database theory. And then unwind is an operator that effectively takes an array. Remember, we can nest documents inside other documents in MongoDB, and we can also have nested arrays. To represent those as an expanded document, we can essentially take that array and turn each document into each element of the array into a single document, including a single element of the array. So, I think the easiest way to do this is to show you some examples and get you used to how we interact with this data. So I'm going to use a data set. It's a UK data set from the Ministry of Transport. The Ministry of Transport does a driving test or a car test on every vehicle over 3 years old for roadworthiness, and it has to be done every year. And they've made anonymized data sets available. We're going to look at one particular data set, 2013, and I'm going to show you how to do some manipulations on this data set with the aggregation framework. So here's an example document in this data set, just to give you an understanding of what's in there. So the ID is the ID created by MongoDB when we do the insert. The test ID is a unique ID associated with each test that's done on every car. The vehicle ID is a unique ID that identifies the car. Because it's an anonymized data set, this would normally be a registration, but of course we want to hide that. Then the test date is the date on which the test was done. You can see that here. Then the test class ID tells you which type of vehicle. I know because I know the data set that number 4 is cars. Then the test type is N for normal as opposed to a retest. The test result is P, which means it's a pass. The test mileage is how many miles on the odometer of the car, or the mileage at the time that the test was done. Postcode is again anonymized, but it's the location, and the make is Audi, and the model is A3. The color is black. The fuel type is P for petrol. There's also a D for diesel. And then the cylinder capacity is the number of cc's of the engine. This is a 1.5 liter engine. And first use date is the date that the vehicle was registered. So this is a fairly standard data set. So there's some manipulations we like to do on this data to get more value out of it. And I'm going to show you a couple of those now in a minute. So we're going to use the MongoDB shell. I'm just going to share my screen for a second. So this is the MongoDB shell. I'm just going to join the shell. You can see over here there is that's the browser, that's the server running in that window. And I'm going to use the VOSA database. And we can see the collections here. And we've got a whole bunch of them. I've been working with this. But the one you're interested in is results 2013. This is the test results for all of the cars tested in 2013. I can show you a document in that data set. Find one. So this is the same structure of document as we just saw on the screen there. So we're going to be able to see all of these values. Now, there is a very large data set. This is a big data set. So if I do a count here, that's a big data set. I can show it more visually in our Compass tool here. If I look at the results 2008, this is the graphical view on our database. So there's 37.4 million documents in this database just up here. So that's quite a big database. And we can see we've got a kind of a statistical analysis of the documents, the color. Guess what? Silver cars are really popular, then blue, then black, then gray. Guess what? Cylinder capacities run a kind of a more normal curve. The most average cylinder capacity is 1.5 liter cars. That's a pretty standard size for the UK. Then we've got a range of first use dates. The fuel type is split roughly 64% petrol and 36% diesel. And then there's a range of makes. Ford is the most popular, and it goes down, Renault, BMW, etc. So you can see this data. So there's rather a lot of data in this, and I don't really want to process 34,000 records every time I do a query. So what I'm going to do is I'm going to just reduce the set of collections here. So I've got a little query here that will do that for me so I don't make any typos. I'm going to just cut and paste this in. So this is the first aggregation pipeline we're going to show you. So it's calling db.results.aggregate. And the first thing we're going to do is we put it inside square brackets because it's a pipeline. So it's an array of operations. And inside the array of operations, there's two operations. There's a limit operation, and then there's a $out operation. And the limit operation says, I just want the first 10,000 records. And I want to put those 10,000 records in the results 10K collection. And now if I just hit return here, well, something's happened. So if we just do db.results 10K.find 1, well, it's the same document as we had in the first one, but let's just look at the total number of elements in that collection. So I do count. And there we are. It's 10K as opposed to the original enormous number. So remember, the original set was, it's a big number, right? We don't really want to do that. That's too many things. So now I'm going to look at the next operation we want to do. So what I want to do now is I want to find, I know for a fact that some of these queries have null values in them, and I want to find the age of a set of values in this database. So what I'm going to do is I'm going to skim the database, and I'm going to take out all of the first use dates that are null. So if I do a query here, what have I done wrong there? Anyway, I need to remove the first. Sorry, I need to show this from the other results set to give you some examples. Results 2013. So we'll find there's lots of dates fields here with null dates. I can't calculate a null date there. So what I need to be able to do is I need to remove the first use dates equals null. Otherwise, I can't work out what time the car was registered at. So what I'm going to do is I'm going to effectively remove all of the null dates here, and I can do that by doing a match here. Okay, so we've made a small collection. Now we're going to do this match here. So what we want to do is we're effectively trying to match for first date not equal to null. So we're going to remove all of the elements that have a null first date on them. What this will allow us to do is make calculations between the current test date and the first use date without worrying about trying to do calculations on null values, because if you subtract current test date from first use date and first use date is null, you'll get an error. So we want to strip those values out. So we run this aggregation. I've already done the limit to 10K, and I'll run match first use date not equal to null, right? So this is a not equal operator. This is exactly like a query we do in the query language, and what we get back is a range of values that are very clearly non-null. Now we want to do a projection. Now the projection we're going to do is built up of a range of values. So the age in microseconds or milliseconds is calculated by subtracting the test date from the first use date. And that's why we had to essentially remove all null use dates, because the first time this tries to subtract the test date from a null, you'll get an error. We then use the age in milliseconds to create an age in years by dividing by this long number here, which turns it into years. See this number over here? It's just a divider. We then want to take the floor, which is another function we can use in the aggregation framework, of the age in years just to give us a round number. And then we want to turn the pass field, which is currently a string, a p, into a number so we can calculate the number of passes and fails. So we use a conditional statement which says if equal test result p, return a 1, else return a 0. So now this projection is going to be a projection operator on the pipeline, which effectively says include the make field, include the model field, include the vehicle ID field, include the test result field, then calculate the age field from floor age, which is floor age in years, which is age in years divided by age in milliseconds, which is age in milliseconds, which is calculated from subtracting test date from first date. So you can see what we've done here is construct quite a complicated object from using some basic operators that the aggregation framework provides. The key thing about project is it can only work with an individual document, so it can't reach forwards and backwards into the documents. So if we run this, and non-null dates is the collection I created by basically running the first aggregation pipeline and piping it into non-null dates, we can run this projection. And of course, it's just a variable in the, this projection is created as just a variable in the shell. And what it will return is this sort of collection. It's being quite compressed now. We just get the ID over here, and then we get the vehicle ID, and the test result, P, the make, the model, type, and then the age and the pass field. Now we want to group these fields, and this is the key kind of reduction phase of the pipeline. So with a $group, what we want to do is we're going to create a brand new ID field. Remember, ID field has to be unique, right? So we can't have multiple makes in the ID field. So what we're saying is we're going to make a new collection with an ID field of make, and we're going to take each document that we meet, and we're going to sum them up, and we're going to count the number of documents. And with an accumulator function sum, we can either pass it in a value, such as mileage, or we can pass it in just a number, which is essentially says, just add this number to the previous number. So this is going to count the total number of makes. And so what we end up with now is a brand new collection with just two fields. So the make, which is now the ID field, which is perfectly fine because all the makes are going to be unique, and then a total count, right? So the total is 1, 1, 1, and then we get 26 Audis and 2 smart cars, and it would go on. I think there's about 600 or 700 makes in the total collection. So effectively what we've done here is we've taken a 37 million record collection and reduced it down to a count of the total number of makes of car that did the test, did the MOT test in that particular year in 2013. So now we could look at the mileage or some other data to get more insight into, of the cars that did those tests, how much mileage had they done and how many tests had they passed. So, in summary, what we've got here, the aggregation framework is a pipeline of operations. The key operations are to select using match, to project by selecting a specific set of fields, saying field 1 or field 2 or field 3 or field 4, a grouping operation that takes those fields and does an accumulation. And the key thing to remember between projection and grouping is that projection works within a document. Grouping runs across all the documents. So it's effectively looking at each document and saying, if there is an ID field that makes this match, then I'm going to run a sum on some set of other fields in the grouping. We can then pipe that out into a cursor and look at it inside the program, or we can pipe it to a cursor and look at it inside the shell. But $out must appear last in the aggregation pipeline. So effectively, if you want to create a new collection from the old collection, then what you can do is you can use $out to pipe the output of the aggregation into a new collection. Now, a couple of things about $out. $out always creates a new collection. You can't append 2 runs of the aggregation framework to the same collection. If you do, it effectively erases the old collection and creates a new one. So if you need to run the aggregation pipeline multiple times and stream it out, what you're going to do is stream it to different collections and merge those collections later. There are a range of accumulators: average, standard deviation, sum, multiply, which can do various transformations on the data as you pass through the grouping stage. And in essence, the aggregation framework provides a very powerful way to reshape and analyze data. But most importantly, if you're running on a sharded cluster, which is the largest cluster MongoDB provides, which can run hundreds to thousands of nodes, the aggregation framework is designed to optimize distributing the workload across those nodes, so you get very efficient parallel processing. So if I was to run that $23 million data set on a 12-node cluster in a high-end Amazon, we could do queries and operations and aggregations and data loads in minutes as opposed to hours. That's pretty much us from the aggregation framework. If you've got any questions, we can handle them in the chat box. Otherwise, we'll see you in a couple of weeks' time for the final episode of the Back to Basics framework, which is moving your application into production. So Paul Turner asks, is that 10,000 the first or a sample 10,000? So Paul, you can take 10,000 using limit, or there is a sample function which I didn't show, which will sample 10,000 documents for you. So you can choose whichever one you want to use. Dino Vitale says, is it possible to get a cheat sheet of the sample commands? Yes, go to the documentation, right? If you go to just type in MongoDB aggregation framework, there's a very comprehensive documentation set online. Lognathan asks if $out collection exists already, will it overwrite? Yes, it will. I think I covered that in the last few notes. Sujit Kumar, suppose I have to fetch records from diff collections, diff collections, then what do I have to do? Sujit, sorry, I don't understand that question. Maybe you can rephrase it. Venkata asks, will lookup be supported in next versions for sharded clusters as well? I would expect that to happen. I don't have a time frame for that, Venkata. Shambhu Kumar, can we have page sorting in it? I don't understand that question. You can definitely take your output and limit it on the output side as well as on the input side, and of course you can use a cursor to allow you to sort. Sunil Kumar Ganta, what are the use cases for MapReduce over aggregation? Again, Sunil, if you need to do computational analysis, if you need to run an algorithm on the data as opposed to just querying or reshaping the data with the aggregation operators, then MapReduce becomes a more appropriate use case. Sujit Kumar, how can I use MongoDB in my projects? Well, if you've been listening to this whole webinar series, you should have a good grasp of that. Amish says, could we not use these aggregations in relational database? What is the difference? Is it parallel? Yes, there are aggregations in relational databases, but the point is there are very few NoSQL databases that will give you an aggregation framework like this. Most NoSQL databases expect you to write code to provide this kind of capability. The point is, building this kind of capability into the database allows the database to do things more efficiently than you could do it, because you're running all of the aggregations on the server side, Amish. If you were running this as a client-side set of queries, you'd have to pull all the data to the client in order to analyze it, and that's very inefficient. So you're leaving the data in place and running the analysis and the queries and the aggregation inside the database engine. That makes it very efficient. Harish, can you give an example of $lookup used in aggregation? I can't here now. I don't have that prepared. This is more of an introductory lesson to the aggregation framework, but there's plenty of excellent documentation online. Ray asked the same question. Again, look at the documentation for lookup. Vinayak Parekh, can you suggest good books which give detailed explanation of the aggregation framework? The best information is the documentation from MongoDB. There is an O'Reilly book, but it's a bit out of date, that does cover the aggregation framework in some level of detail as well. It's called MongoDB, the Definitive Guide. Actually, I just want to know, Sujit says, actually, I just want to know that in MySQL there were joins. Is there any alternative methods in Mango? It's Mongo, not Mango, Sujit, and no, $lookup is the only join capability, and it's in the aggregation framework. Mod Ramzan Rosali, let's say I have a user profile and record their transaction sales expenses using manual reference at 3 collection. When I need to aggregate, do I need to use embedded document instead of manual references? Or you can still use your manual references, Mod. There's no reason to. You can use an aggregation framework on the individual collections, and you can use lookup to join them together. Simon Downs, does the aggregation framework only run as batch, or can it run in real time and change the curve? Simon, we don't currently support that. There is a capability in 3.4 which is due for release at the end of the year, which may address that concern. It gives you a view level approach to the aggregation output, so effectively you'll get a dynamic view of your data. But I haven't enough detail on that to know if it absolutely addresses your concern. Malik, how can we create relations between different collections with $lookup? Otherwise, there is no mechanism. The reason we don't use joins or allow them in MongoDB is if you've got a distributed cluster of 100 nodes, doing joins requires you to literally look at all the nodes in the collection, and that's very expensive. And I think we've covered most of the questions there. I'll hold on for another couple of minutes in case any more pop in. Okay, I think that's covered everything. Folks, thanks very much for your time. I hope to see you for the last webinar of the series in a couple of weeks' time. Don't forget to sign up for MongoDB Europe. Early bird ends on Friday. Talk to you soon. Bye.